Okay, let's go ahead and try an example of the second type. So if you look back, our second type is log on both sides. Okay, so we're going to go ahead and do an example of that. Of course, I'm not going to tell you what type of problem it is. When you see the problem, you have to recognize it. You have to see it and recognize which process that you're going to have to go through. So we're going to solve for x again. And so we have log base 13 of 4x plus 3 equals log base 13 of 4x squared. First of all, when you're doing a log on both sides type of problem, you want to make sure that the log on both sides are the same log. If they're the same log and you're saying log of this equals log of that, then wouldn't you be able to say that this has to equal that? Why, yes, of course. So the first step would be to set arguments equal to each other, meaning we do 4x plus 3 equals 4x squared. So we've effectively gotten rid of the logs, and so now you just have to solve algebraically. Well, this is just a quadratic, so we're going to want to get all the terms to one side. So we're going to subtract those to the other side. So you have 0 equals 4x squared minus 4x minus 3. Well, when you're doing something like this, you want to check to see if it's factorable. So we make the big X. Well, what do we put at the top? Well, that's going to be negative 12. That's because A times C, 4 times negative 3, that's negative 12. We're going to put negative 4 at the bottom because that's your B value. And then you're supposed to find two numbers that add up to negative 4 and multiply to negative 12. Well, those two numbers would be, I believe, 2 and negative 6. So we take both of these numbers, we divide it by A. So divide both of these numbers by A. We divide by 4, and then you simplify whatever you can. And so this simplifies over here to 1/2, and this simplifies over here to negative 3/2. And so then the factored form, if you do bottoms up, so this 2 comes up, so it becomes 2x plus 1 times, and then this bottom, this 2 comes up, and we have 2x minus 3. Okay, and so this is equal to 0. Do y'all remember when we did quadratics? How do you solve when you're in factored form? Well, you set each of the arguments, each of the factors equal to 0. So you have 2x plus 1 equals 0, and 2x minus 3 equals 0. If you subtract the 1, divide by 2, you get x equals negative 1/2. And then you add the 3, divide by 2, you get x equals 3/2. Are we done? No, of course we're not done. We always have to check. Okay, so when we're solving equations, we need to check to make sure that there are no extraneous solutions. Y'all remember that word, extraneous solutions. We want to make sure there's no extraneous solutions. Okay, so we plug in negative 1/2. So you have log base 13 of 4 times negative 1/2 plus 3. And we're asking, does that equal log base 13 of 4 times negative 1/2 squared? Well, we do 4 times negative 1/2. That's negative 2 plus 3. That's 1. So you have log base 13 of 1. Does that equal log base 13 of 4 times negative 1/2 squared? Well, negative 1/2 squared, that's just negative 1 squared over 2 squared. So that's 1 over 4. And 4 times 1/4, that's log base 13 of 1. And log base 13 of 1, what is that? Well, that's 0, and this equals 0, and so therefore x equals -1/2 works. Now let's go ahead and check x equals 3/2. So you have log base 13 of 4 times 3/2 plus 3, and then equals log base 13 of 4 times, and then you have 3/2 all squared. So if you do 3/2 of 4, that's going to get you 6. So you have log base 13 of 6 plus 3. So over here right now, by the way, we're checking x equals 3/2. Okay, and then log base 13 of 4 times, and then 3 over 2 squared, that's 3 squared over 4 squared. So that's going to be, sorry, over 2 squared, which is 9 over 4. 4 times 9 over 4, that is 9. So you have log base 13 of 9 equals log base 13 of 9. So check, that works. Both of these are solutions. So x equals -1/2 and x equals 3/2. Okay. So there you have it. You now know how to solve an equation where there's log on one side or the same log on both sides. Happy day.